Hello everyone. Hello students. Good afternoon. Good afternoon to one and all. Good afternoon, Vaishnavi, Sanika, Chandana, Pratyusha, Sakshi. Good afternoon to all. Am I audible? Students are audible? Yeah, hello, hi. Yeah, fine. Good, good, good. Okay. So, in the last class we have discussed about the compounds, right? So, what are the two compounds? Potassium dichromate and potassium permanganate, right? So today we are going to discuss about potassium permanganate. But before moving on to that, I just want to ask you guys a question. Okay. So we have prepared potassium dichromate in the previous class, right? How many steps were involved in that preparation process? Can anyone tell me? Very good. Three steps. Okay. So from which ore we have prepared the potassium dichromate? So can you name the ore? Very good, Sakshi and Vaishnavi. So can anyone name the ore? Chromite ore. Very good, very good. It is chromite ore. What is the formula for chromite ore? What is the formula for chromite ore? What is the formula for chromite ore? FeCr2O4. Very good, very good. Sanika, why you have made a small mistake over there? It is FeCr2O4. Very good, very good. Fine, good. Yeah, fine, good. And the next question is, what is the color of potassium dichromate? What is the color of potassium dichromate? It is a red orange crystal. Okay, it is a red orange crystal. Okay, fine. So we had two ions. One is chromate and the other one is dichromate. What is the structure of chromate ion? Formula for chromate ion is CrO4 2 minus, right? So what is the structure of chromate ion? What is the structure? Very good, Vaishnavi. It is red orange in color and it is tetrahedral. Very good. So, how many tetrahedrons were there in dichromate? How many tetrahedrons we had in dichromate? Very good. What is the oxidation state of chromium in potassium dichromate? Oxidation state of chromium in potassium dichromate. Very good. It is +6. Great, great. So, chromate and dichromate are interconvertible. How to convert chromate to dichromate? How to convert chromate to dichromate? By adding an acid or by adding a base? Yeah, very good, Sanika. It is by adding an acid like sulfuric acid, etc., etc. Yeah, yeah, yeah. Good, good, good. Great. Very good, students. All of you are doing really great. So, hats up to you all. So, now I think we can move on to the today's session. Okay. So the today's compound is potassium permanganate. So we'll do this, and after completing this, we can move on to the F block. Okay, we'll try to complete as much as possible. So the formula for potassium permanganate is KMNO4. Okay, so like we have prepared K2Cr2O7, here also we are going to see the preparation for KMNO4. Okay. So first what you have to do, you have to take the manganese dioxide, which is called as pyrolusite ore. Manganese dioxide is otherwise called as pyrolusite ore. Okay, so the name of the ore is very important and the formula is MnO2. And we have to add an base. Potassium hydroxide is the base, which is called as caustic potash. Okay, and after adding an oxygen, it forms potassium manganate. K2MnO4 is potassium manganate with the release of H2. But still, we did not get the permanganate, right? So we have one more method also to prepare this potassium manganate. So that method is, this is one of the method. The next method to prepare potassium manganate from pyrolusite ore is by adding potassium carbonate and potassium nitrate. So these two are the carbonate and nitrate containing potassium salts. Okay. So instead of using caustic potash and oxygen, we can use potassium carbonate nitrate also. So from that also we will get potassium manganate. Okay. Now to this potassium manganate, you have to add water. So if you add water to potassium manganate, you can get potassium permanganate. Got it? And MnO2 is coming out again. What was this MnO2? It is the pyrolusite ore. So we have started with pyrolusite ore, and at the end we are getting back that pyrolusite ore in the preparation process. So what you can do, you can use the MnO2 pyrolusite ore, which is coming out as a byproduct as a starting material for the next cycle for the preparation of potassium permanganate. Okay. So this is one of the method of preparation for potassium permanganate. Okay. So any doubt, students? So what we are doing, there are two steps. We are preparing potassium manganate by using any one of these two steps, and the final step is this. Got it? Next, we will study the laboratory preparation of KMNO. Shall we move on to the laboratory preparation? Have you all noted this down in your notebook? Any doubt? Okay. So the next is, okay, my dear. So the next is laboratory preparation of KMNO. So here what we have to do, we have to take some manganese salt, manganese 2 plus containing salt we have to take, and we have to add peroxodisulfate, S2O8, 2 minus is called as peroxodisulfate, and by adding water into it, we'll get MnO4 minus permanganate we are getting. And sulfate ion is coming out, H plus is coming out. So the structure of peroxodisulfate is this. So we have oxygen-oxygen linkage in the peroxodisulfate form. It is S2O8, 2 minus. So we can prepare permanganate from manganese salt in the laboratory. Okay. And we also have the industrial preparation of KMNO. So the industrial preparation is taking the manganate ion and converting that manganate to permanganate by electrolytic oxidation. Electrolytic oxidation. So you all know what is electrolysis process, right? So in electrolysis, we will have a container beaker, and we will have some electrolytic solution inside it. And two electrodes are dipped inside that, and one is a cathode and the other one is an anode. Okay. So they'll be connected internally, and by turning off on the switch, and the ions which are present, the cations and anions will be there in the electrolytic solution. So all the cations will move towards cathode and anions will move towards anode. So some of the compounds are settled at the surface of the electrodes. Okay. So this process is called as electrolysis. So using this electrolytic oxidation process, we are getting the permanganate from manganate in the industries. Okay. So very easy. So this is about the preparatory part of KMNO. Okay. First is the general preparation. Second is the laboratory preparation. Third is the industrial. Industrial means large scale preparation. Laboratory means small scale preparation. Got it? Students, any doubt from the preparation part? Shall we go with the properties of potassium permanganate? Okay, no problem. Good. So the properties of KMNO4. The first property is the color. Okay. So here the KMNO4 color is dark purple. Okay, it is anhydrous needle-like crystal. You can see the needle-like crystals of KMNO4 in the picture, right? So it is a dark purple needle-like crystal in the anhydrous form. Anhydrous means, what is the meaning of anhydrous, students? What is meant by anhydrous? What is meant by anhydrous? Moisture is free. Okay, no water content will be present inside that particular system. Okay, water free compound. So it is called as anhydrous. This and yeah, no water will be present there. So this is the first property. And the second property is it is isostructural with KClO4. So KClO4 is one of the compound. Isostructural. What is meant by iso? Iso means same. What is meant by iso? Iso means same. So you all know what is structural, right? Isostructural. Same structure. So KMNO4 is similar in structure with, yes, very good, Sanika. It is similar in structure with KMNO4. KClO4 is similar to KMNO4 and KMNO4 is similar to KClO4 in terms of structure. So I'll show you the structure. So you can see. So of them contains potassium ion K plus and four oxygens are also same. So instead of manganese, we have chlorine and KClO4 form. Okay, both of them are tetrahedral in geometry. So both of them are tetrahedral in. So you can able to see the tetrahedral, right? In both the compound. Tetrahedral means what? It the one which has four faces. Okay, so it is called as tetrahedral. So it is isostructural with KZlO4. So all the points which we are discussing under KMNO4, they are also very important. Okay, like K2Cr2O7, KMNO4 properties, reactions, chemical properties, everything is important. Preparation is important. So don't just skip study all the points. Got it? So the third point is about solubility. So we have dissolved K2Cr2O7 in water and we have studied that it is soluble in water. But when we come to see about KMNO4, this is just moderately soluble in water. Just see here, if I add this some of the needle like KMNO4 into the water, the very few KMNO4 are left inside the water. Okay, they did not get dissolved. It is just partially soluble. It is not completely soluble like potassium dichromate. Okay, so if we can able to see the needle-like crystals, right? So which doesn't get dissolved it in the container. So some of the KMNO4 is left out. Yeah, so it is moderately soluble in water. And the fourth point is if you heat this compound, if you give the strong heating, it decomposes to K2MnO4. What is K2MnO4? Potassium manganate. Okay, potassium manganate. And KMnO4 is potassium permanganate. What is the difference between these two? So in permanganate, we have MnO4 minus. In manganate, we have MnO4 2 minus. So this is the difference. So since we have only one potassium, it is K plus MnO4 minus. But here we have K2, 2 potassium. So it is 2K plus and MnO4 2 minus. MnO4 2 minus. Okay, so here 1 minus and 2 minus. Permanganate and manganate. Got it? So on strong heating, permanganate is decomposing to manganate ion. This is the fourth point. So the next point, fifth point is, so any doubt from these 4 points, students? Everything is clear for all of you? Okay. So the fifth point is, the ions are tetrahedral. Ions are tetrahedral. Which ion? Permanganate and manganate. So the first compound is permanganate. Okay, this is permanganate. Since it has only one minus, it is permanganate and here it is manganate. Okay, both of them are having the same structure, tetrahedral structure. So in permanganate, we have only one minus, but here we have two minus. So that is the difference. Both of them are tetrahedral in nature. But when you look into that potassium dichromate and chromate, So in chromate, we had only one tetrahedral, and in dichromate, we had two tetrahedral. No, here in both the cases, we have only one tetrahedral. Got it? So you have to just compare these two compounds in terms of structure and everything, and you have to study. Then only you will not get confused, or you will not forget. Got it? Then the next point, the very important point about this is manganate ion is paramagnetic, but permanganate ion is diamagnetic. So can anyone explain this? Why manganate is paramagnetic and permanganate is diamagnetic? Can anyone of you explain? All of you know what is meant by paramagnetic character and what is diamagnetic character, right? So what is meant by paramagnetic? The compound which has unpaired electrons are called as paramagnetic in nature. And diamagnetic means if all the electrons are paired, then we call that as diamagnetic. Now using this concept, tell me why manganate is paramagnetic. All of you give a try for this. Just think of it. What is the formula for manganate ion, my dear students? Manganate is MnO2 minus. Okay. So how to find out whether this compound is paramagnetic? Because the magnet has two minus here. You mean the charge? Sakshi, what do you mean by the two minus? You mean the charge? No, no. Okay, I'll explain you. I'll explain you. Can anyone, can any other wants to try? Sanika is saying it contains three unpaired electrons. Okay. Any other explanation? Any other wants to try? Any other wants to try? Okay. Okay, so I'll explain you. No worries. So, to find out whether a compound is paramagnetic or not, first we need to find out the oxidation state of that compound. Okay. So you need to find out the oxidation state of manganese. So let me take manganese as X, and each oxygen has -2 charge. We have 4 oxygen. So 4 into -2 is Tanika, the oxidation state of manganese is +5. Okay, let's check. Let's check. Yeah. So here it is -8 and it has gained 2 electrons, right? Jyoti is saying 4 and 5. Okay, okay, students, we'll do. All of you are trying really great. So just listen. Sorry, sirs. Yeah. So very good. So it has gained 2 electrons. So +2 is equal to 0. So X is equal to +6. So oxidation state of manganese is +6. So now how we have to compare? We have to first go for the configuration of manganese. It is 3d5 4s2. So this is the electronic configuration for normal manganese, right? This is the electronic configuration. Now in manganate ion, oxidation state is +6. So we have to remove 6 electrons, right? So 2 from s orbital and the remaining 4 from d orbital. So manganese +6 compound contains how many electrons now? 3d1 and 4 is 0, right? 3d1 and 4 is 0. So how many unpaired electrons are there now? All of you tell me now. How many unpaired electrons are there for manganate? Yeah, this one. It is not 2, it is not 3, it is not 4. It is 1. So all of you can able to find out the number of electrons now by seeing the compound, right? So hereafter you guys will not make any mistake now. Yeah, mistake in my cal. No issues, Anika. So from next time onwards, don't do any mistake in your calculation, all of you. Students, clear? So while doing the magnetic moment calculation also we have done in the same method, right? So we have calculated oxidation state first, and accordingly we have got the number of unpaired electrons and substituted in the formula, and we have got mu, no? So then why are you making the same mistake again, all of you? So to find out the oxidation state first. Okay, then remove the electrons. So for this purpose only, I have told you to memorize all the elements, atomic number and electronic configuration in the first class itself. Okay, so everything lies in that only. So without knowing the electronic configuration of the element, without knowing this step, the next step will be very difficult for you. So all of you who did not study the elements and its electronic configuration, especially 3D elements. Okay, so if you have not memorized so far, try to do the memorization part today itself. Okay, it will be difficult to solve many topics. So do that. So we have one unpaired electron. Okay, so we have one unpaired electron. So the compound is paramagnetic in nature. Compound is paramagnetic in nature. Okay, and what about for this is the story. This is the story of manganate ion. So we have given the conclusion why manganate is paramagnetic. What about permanganate ion? What is the formula for permanganate? It is MnO4 minus or KMnO4. What is the oxidation state of manganese and permanganate? Have you calculated? Very good. It is plus 7. So how it is plus 7? X minus 8 plus 1 is equal to 0. X is equal to plus 7. So here if you see, all the electrons, 3d5 and 4s2 is the configuration. Very good, Sanika. It is 3d5 and 4s2. So all the 7 electrons are lost. So we are left with 0 electron. So 0 unpaired electron. So it is diamagnetic in nature. It is not dimagnetic, it is diamagnetic. Okay, diamagnetic name should not come. These are the mistakes. Sorry for it. So it is diamagnetic. So now all of you can able to understand why manganate is paramagnetic and permanganate is diamagnetic, right? Any doubt? So this is the criteria which you have to follow for any type of ion, not only for these two, for any type of ion. If you want to find out the paramagnetic, diamagnetic character, first to find out the oxidation state and go with the process. Okay, fine. So the next is the chemical properties. So these are some of the six very important general physical properties of these two ions. Now the next topic is chemical properties of potassium permanganate. So like potassium dichromate, potassium permanganate is also the one of the very powerful oxidizing agent. Okay, but according to the medium, the oxidizing power will change. Okay, so we have three medium: acidic medium, basic medium, and neutral medium. So in each medium, the oxidizing power will change. I will give you the equation that in which medium oxidizing power is more and in which medium it is less, and what is the equation. So first let's go with acidic medium. So in acidic medium, we have to add an acid, right? So the acid which I'm adding here is sulfuric acid. Okay, so this is the potassium permanganate. Now here, what is meant by an oxidizing agent? Can anyone give me the definition for oxidizing agent? In the last class also I have told no. What is meant by oxidizing agent? What is the definition for oxidizing agent, my dear students? Electron acceptors. No, no. Oxidizing agent, I must. Oxidation means loss of electron. Oxidizing agent means electron acceptors. Electron acceptors are called as oxidizing agent. So K-metaphor is an oxidizing agent, I'm saying. So in the reaction medium, the compound will give out 5 oxygen. Compound may give out 5 oxygen. Okay, so 5 oxygens are lost in acidic medium. But when you come to basic medium, basic means we have to add a base. Potassium hydroxide is added here as a base. So in basic medium, only one oxygen is getting lost. Okay. And in neutral medium, you see three oxygens are lost. Neutral means we are adding water. So here three oxygens are lost. So the oxidizing power, if more number of oxygens are lost, then the oxidizing power is more. Okay, but so in acidic medium, oxidizing power is more, then in neutral medium, then at last only basic medium. Got it? So we have to check for the oxidation state of manganese. Then only you will be able to understand. I will explain you. So we all know that the oxidation state of manganese in KMnO4 is +7. So let me put +7, +7, +7 everywhere. Okay. So now, can anyone tell me the oxidation state of manganese in MnSO4? In MnSO4, what is the oxidation state of manganese? We know that sulfur is SO4 2 minus. Means Mn is 2 plus. Okay. So manganese is going from my +7 to +2. So what is the meaning? If something is going from +7 to +2, what is the meaning? +7 to +6, +6 to +5, +5 to +4, 4 to 3, and 3 to 2. So how many electrons are gained by manganese? 5 electrons are gained by manganese. Yes, very good. 5 electrons are gained by the manganese. 5 electrons are gained by the manganese in acidic medium. So what about here? In K2MnO4, what is the oxidation state of manganese? Just now we have calculated, no? What is the oxidation state? K2MnO4 is manganate ion, no? What is the oxidation state? Very good, it is +6. So if it is +6, how many electrons are lost by manganese? Sorry, how many electrons are gained by manganese? So it is the decrease in the positive charge. Decrease in the positive charge means it has gained the electron. Okay. So oxidizing agent means electron acceptors. It has gained. Very good. One electron is gained. What about the last compound? MnO2. What is the oxidation state of manganese in MnO2? Very good. How to calculate? How it is 4? Manganese is taken as x and each oxygen -2. So -4 is equal to 0. X is equal to +4. So +7 to +4 means 3 electrons are gained. 3 electrons are gained, or we can say that 3 oxygens are lost. Okay. So in case of acidic medium, the electron accepting property is very, very high. In case of neutral, it is little bit low. In case of basic medium, it is still very less. Okay. So all of you can able to understand, right? It is a powerful oxidizing agent in acidic medium, then neutral, then basic. Clear? So shall we go with some examples according to the medium? So this is the general equation. This is the general equation. Now yesterday we have, in the last class we have studied for K2Cr2O7. No? Like K2Cr2O7 has converted sulfide to sulfur, ferrous to ferric. So like that we will see some examples. So first we'll go with acidic medium. So this is the reaction we have studied now in the previous slide. So that will be there in all the reactions. Okay, now I'm going to tell you which is going to convert it to what compound. So hydrogen as sulfide is again getting converted to sulfur. So -2 to 0. So -2 to 0 means it is moving towards positive side. So it is oxidation. How many electrons are lost by this sulfide ion? How many electrons are lost? -2, -1, 0. So 1 electron, 2 electrons. So 2 electrons are lost. Yeah. Sulfide is getting converted to sulfur. Then the next is sulfur dioxide to sulfuric acid. So in sulfur dioxide, the oxidation state of sulfur is +4. And in case of sulfuric acid, the oxidation state is +6. +4 to +6. How many electrons are lost by one sulfur? How many electrons are lost by one sulfur? If you are seeing an increase in the positive oxidation state, then it is called as oxidation. Okay. Yeah, two electrons are lost by sulfur, and this potassium permanganate only gained those two electrons. Potassium permanganate only gained that two electrons which has been lost by sulfur. Good. Third example is arsenite to arsenate. Arsenite to arsenate. What is oxidation state of arsenite? Here in the first compound. So take this as X. So 3 into minus 2 minus 6 plus 3 is equal to 0. So X is equal to plus 3. So here it is plus 3. Not about here. So X minus 8 plus 3 is equal to 0. So X is equal to plus 5. So here it is plus 5. So here also for one arsenic thing, the two electrons are lost. Yeah, plus 5. Two electrons are lost. Very good. Arsenite to arsenate. The name is very important. Okay, the name and the formula. Then the fourth example, sulfite to sulfate. So in sulfite, the oxidation state is plus 4. In sulfate, what is the oxidation state? X minus 8 plus 2. Okay, X is equal to plus 6. Yeah, X is equal to plus 6. Very good, Sakshi. So two electrons are lost. Sulfite to sulfate. Then the next is nitrite to nitrate. Nitrite is plus 3. Nitrate is plus 5. Two electrons are lost. Then the next is ferrous sulfate to ferric sulfate. Yesterday we have studied the same thing. Like K2Cr2O7, this one also will oxidize. Ferrous to ferric. Okay. So shall I move on to the next slide, students? Have you all noted? Okay. The next example. The next example is iodide to iodine. So -1. -1 to 0. So here how many electrons are lost by one iodine? Only one. Okay, only one. Very good. Next is peroxide to oxygen. Hydrogen peroxide to oxygen. So in peroxide, the oxidation state of oxygen is -1. In case of normal oxygen, it is 0. Okay, so 5 oxygens are gained for 5 compound, and peroxide is getting converted to oxygen. The next is oxalic acid to carbon dioxide. Oxalic acid to carbon dioxide. Oxalic acid to carbon dioxide. So here the oxidation state is plus 3. So all of you can able to find out, no? See, it is nothing but C2O4H2. C2O4H2. So we are going to find out the oxidation state of carbon. We have two carbons, so 2H. 4 into -2 is -8. So for each hydrogen, we have to give +1. So we have two hydrogens, so +2 is equal to 0. 2X is equal to +6, and X is equal to +3. So this is how we have got this 3 plus oxidation state for carbon in oxalic acid. And here in case of carbon dioxide, we all know how to calculate. It is +4. So +3 to +4 oxidation. Okay, oxidation. So these are the reactions and the conversions happening in case of acidic medium. So in all the acidic medium reactions, you might have observed 5 oxygens are gained. So 5 oxygens are getting lost here in the reaction. No? So the potassium permanganate is gaining those things and getting converted. So shall we go with the reactions based on basic medium and neutral medium? Any doubt from acidic medium reactions? Clear for all? Okay. So now the basic medium and neutral medium reactions are, yeah, here you see, iodide is converting to iodate. So in acidic medium, iodide was converted to iodine, right? I minus was converted to I2, iodine. So this is called as iodine. This is for acidic medium. But in case of basic medium, it is getting converted to iodate. This IO3 minus. IO3 minus is called as iodate. K plus and IO3 minus. So to find out the oxidation state of iodine, we can put +1 plus x minus x is equal to 0. So x is equal to +5. So -1 to +5. So this is very important. This is one of the J equation. Okay, in basic medium, iodide was converted to. Iodide was converted to was the question. Okay, in basic medium, it was converted to iodate. In acidic medium, it was converted to iodine. Okay, so all these are the very minute things, but which are very important. That's why you have to study very carefully. Okay, all the inorganic chemistry lessons are very, very important. Each and every line is important. The next is manganese sulfate to manganese dioxide. So in manganese sulfate, we have +2 oxidation state containing manganese, and in manganese dioxide, it is +1. So here 2 electrons are lost. Sulfate to dioxide. Then third is thiosulfate to sodium sulfate. Sodium thiosulfate to sodium sulfate. Thiosulfate to sulfate. So +2 to +6. Okay. So these are the reactions of the basic and neutral medium. Got it? So the first reaction was asked previously. This is very important. The other two are also very important. So here we are completing the oxidizing property of KMnO4 in acidic, basic, and neutral medium. So I hope this is very clear to all of you. The next topic is uses of potassium permanganate. So shall we go to the uses topic, my dear students? Uses. The first uses, it is KMnO4 is used in the volumetric titration, volumetric estimation, we can say, like an estimation of ferrous salts, oxalates, or oxalic acid, and hydrogen peroxide. So all these compounds estimation processes was done by volumetric analysis, and this KMnO4 is used in the burette. So has anyone gone to your labs, school labs? Have you seen this burette, pipette, conical flask in your labs? Have you ever done your practical chemistry in your schools? Do you know what is burette and pipette? Guys, I'm asking you only. Have you ever been used to this? Yeah. So we have the burette in the burette stand in the laboratory, no? So in that burette stand, we will fill potassium permanganate solution only. So which looks purple in color. So in that volumetric analysis process, so this potassium permanganate is used as one of the titrating agent. Okay, so for estimation of the salts. And the next use is it is used in the bleaching of wool, cotton, silk, and other textile fiber also. So for bleaching process, we are using this KMnO4. This is the bleached, unbleached wool, and this is the bleached wool. So you can able to see the difference, right? After doing the bleaching of wool, so it looks good, no? So it is KMnO4 is one of the component in the solution, bleaching solution. And the next is used for the decolorization of oils. All of you know what is decolorization, right? For oil decolorization process, we are using this KMnO4 again. And the next use is the alkaline KMnO4, which is called as base reagent. Alkaline means basic. Basic KMnO4 is used as an oxidizing agent. It is used as an oxidizing agent. Base reagent is very important. It is nothing but alkaline KMnO4. So these are the 4 uses of potassium permanganate. Very important uses. Got it? So with this, the D and D block element, the topic is getting over for this lesson. So what we have studied from the first, so we have studied some general properties in the beginning, right? Some of the general properties in the beginning, many general properties we have discussed. So do you remember the general properties? What is the first general property you have discussed with sir? Can anyone tell me the first general property that have been discussed in this lesson? And now you remember. What was the first general property? Oh my God. It was atomic and ionic radii, no? Atomic and ionic radii. Okay. Yeah. Atomic and ionic radii. And the second is ionization enthalpy. Then color formation of colored compounds, variable oxidation state, formation of colored compounds and catalytic property, magnetic property, etc., etc., etc. Okay. So the second very important most important topic is the compounds. So K2Cr2O7 and KMNO. So in these two, first is preparation, the next is some of the general physical property, and the third is the oxidizing nature of these two compounds. So these three topics were discussed for the two compounds. Okay. So before this, before studying this general property, you might have studied some of the introductory part of this 3D elements, 4D elements, etc. So I hope you all of you have memorized the 3D series. If you have not done it, please try to do it. And those who have already memorized the 3D series, try to memorize the group elements. So which group you have to memorize means, yes, and alloy formation is also one of the general property. So how you have to memorize this? Memorize group wise. Like you have to memorize the very important groups to be memorized are, sorry, the very important groups to be memorized. They are scandium. Okay, scandium group members you have to memorize. And chromium. Okay, chromium, manganese, iron, cobalt, nickel, copper is very important, zinc is very important. So these six group members are very important. Try to memorize group wise. So first, try to memorize the 3D series. So 3D series from scandium till zinc you have to memorize. Then now group wise. Group wise means if I take for zinc group, if I'm taking the zinc group, zinc, cadmium, mercury will be there. And if I take copper, which is before this zinc, copper, silver, and gold. Okay, so like this, the group wise manner, vertical column you have to memorize. So don't have to go for the 6D series. Okay, so learn 3D, 4D, 5D. So these three rows are important enough to memorize. Okay, so study three elements, memorize three elements in the group wise manner before coming to the next. Okay, so today I'll stop here. So in the next class we can discuss about the F block elements. Okay. So any doubt from the D block, from the topics which we have discussed so far? Okay. Okay then. So meet you all in the next session, students. Thank you so much. Take care. Bye bye.